All right, so as we work through this, when you have these quadratic equations, they're going to be factorable. So none of them will be prime, they'll be factorable. There are quadratic equations that are not factorable. That's going to be a separate section. So that's where you may remember the quadratic formula. That's where that comes into play. So you'd have to use quadratic formula to solve those equations. But in this section, you're going to solve them by factoring. That's how you're going to solve these quadratic equations. So let's look at what a quadratic equation looks like. So a quadratic equation is going to have this form. It will be ax squared plus bx plus c. So remember that ax squared plus bx plus c? Remember when we did the AC method? We talked about ax squared plus bx plus c? And equal 0. So ax squared plus bx plus c equal 0. And a, b, and c can be any real number. Any real number. So it can be decimals, it can be fractions, it could be irrational numbers, rational numbers, but a cannot be 0. B can be 0, C can be 0, but A can never be 0. The reason is if A is 0, what's 0 times x squared?
0.
So that term goes away. This is what kind of equation now?
Binomial.
No. I was hoping you would say linear.
Linear?
No.
That's linear now.
At least he sees the opportunity.
So it's a linear equation. A quadratic equation, you have to have the largest exponent being 2. So if A is 0, then that's no longer there. You now have a linear equation. So since we're talking about quadratic, then this A can never be 0. B can be 0, because if that term goes away, you still have a quadratic, because what's the largest exponent? 2. If C is 0, that's okay. It's still quadratic, because what's the largest exponent? 2. All right? All right. Now, whenever it's in this form, though, and it's not always going to be in that form, but if it's in this form, ax squared plus bx plus c equals 0, that's called standard form. So that'll be standard form. So when we get to some problems where it looks like a real quadratic equation, the first thing you do is make sure it's in standard form. So remember we did the factoring and we had that x squared being last and sometimes we put it first?
Mm-hmm.
That's where we put in descending order. Remember the word descending order?
Mm-hmm.
That will be in descending order. Okay, so let's talk about another thing you're going to need to do this section. So let's suppose we had this. So suppose I have 4 times x equals 0. 4 times x equals 0. And I asked you to solve this equation.
X is 0.
Yeah, the only way the left side can be 0 is if x is what? 0. That's the only way, right?
Yeah.
Okay? And in fact, I'm going to ask you this. Is this quadratic or is this linear?
Linear.
That's linear, because what's the largest exponent? 1. That's linear. So really, to solve this linear equation, you could have just divided both sides by 4. But I didn't want you to do that. I just wanted you to be able to look at this and say that in order for the left side to be 0, 4 times what? 0?
0.
0. So x has to equal 0. So what if you had this? What if you had 4 times x plus 2 equals 0? What must x be in order for that to equal 0?
A negative 1/2.
So you're telling me that if I plug in negative 1/2 in for x, you're telling me that negative 1/2 plus 2 times 4 is going to be 0?
No.
No. Because what's negative 1/2 plus 2? 1.5? 1.5 times 4 is not 0.
Well,
What?
4 times a negative half should
What'd
be
you say?
-2, right?
Negative 2. Negative 2. Why'd you say negative 2, by the way?
Because you need a -2 plus 2.
Oh,
Okay,
negative
all right.
zero.
So she's using the fact that in order for this to be 0, she's looking at this x plus 2.
Yeah.
Then what that means that x plus 2 has to be what?
0.
0. Because 0 times 4 is going to be what?
Zero.
0. And in order for this right here to be 0, in order for x plus 2 to be 0,
Gotta cancel.
then x must equal what?
-2.
Negative 2. So notice what she used, though. She didn't distribute. That's not what I want you to use here. Because remember last semester, that's what you did. You distributed a 4, and then you brought the, this is what you did last semester. You said 4x plus 8 equals 0, correct?
Yeah.
Then you subtracted 8. 4x equal -8, and then you divided by 4, and you got x be -2. That was last semester. I'm trying to get you to think about what you're going to need here, though. So I want you to think about the fact that in order for this product to be 0, that's a product, y'all see that? 4 times x plus 2. So you have these two things, and they're being multiplied together, and their product is what? 0. So in order for that product to be 0, then one of those factors has to be what?
A zero.
A 0. And it can't be this one because that one's what?
A 4.
4. So this one has to be one that's what? 0. And all you do is just figure out, well, what number plus 2 is 0?
Yeah, okay.
And so you just do this right here. Okay? So that's what I wanted you to use, this idea here. So then, so then we have this. All right, suppose I had that now. Think about what we just talked about. Think about what we just talked about. What must x be? What must x be in order for this product to be 0? Okay, all right. So someone said positive 2. You understand why positive 2 would work? Because look, what's 2 minus 2?
0.
0. 2 plus 3 is what?
5.
5 times 0 is still what?
Zero.
Okay, so I agree that x equal 2 is a solution.
You could also put the -3.
Okay, and also what? -3. Because that also can be what? 0. So I had to figure out, well, what makes this 0 and what makes this 0. So this is 0 and x is 2, so 2 is a solution. This is 0 and x is what?
-3.
-3. Because all you do is just set this equal to 0, so x is what? -3. So remember we talked about the fact that in order for this product right here to be 0, then one of them had to be 0. It can't be this one because that's 4, so it has to be this one. So we just have to figure out where's x plus 2 equal to 0. That was a question. So x plus 2 equals 0 when x is -2. Over here, though, I have a product of 0, but both of them have the variable x in it. So this can be 0 when x is what? -3. And this can be 0 when x is 2. So this one here, so when you said solve this equation had how many solutions?
2.
2. This equation right here had how many solutions?
1.
1. Okay, now, when we said these two factors multiply together 0, and then I figure out what makes each one 0, that's called the zero factor property. So the zero factor property. All right, zero factor property. And so the zero factor property says this. If you have 2 or more factors, I'm just going to say 2 of them, A times B. If A times B equal 0. So if I'm telling you that I have 2 factors whose product is 0, then based on what we just said, if I have these 2 factors whose product is 0, then one of them has to be what?
Be 0.
0. So then either A is 0 or what?
B is zero.
B is 0. So one of them has to be 0.
Mhm.
So that's a zero factor property. So as we do these problems, when we solve these quadratic equations by factoring, you're going to use a zero factor property.
This is not too bad.
Well,
It gets
no,
worse.
I mean, it's really isn't bad as long as you remember how to factor.
Mhm.
Now, nothing here involves factoring at all.
Right, that's why I like it so much.
All right. So watch how this works. So suppose then I had this. I'll do a simple one. Okay. Suppose I'm not going to tell you which problem this is yet, but let's suppose we had this. Suppose I said solve x squared plus 2x minus 36 equals 0. So I want you to solve this equation. Now, what kind of equation is this? Quadratic. Okay. So I want to find out what number can I plug in for x, and that size can be equal to 0. Okay, so the idea is to somehow get it to look like this. So if I want this right here to look like this, I've got to use what?
Factoring.
Factoring. Got to use factoring. So the next thing you do is to factor.
X to both sides.
So xx. What else?
It's got a negative sign, so
Come on, guys. You're supposed to know how
Well,
to
you also
do
got
this more
the-
efficiently.
You got the 2x.
36.
Well,
You want 36. So give me two numbers with project is 36.
yeah,
6 times 6 not going to give you that 2 though.
9.
9 and 4.
9 and 4.
nope,
It
that
won't
won't.
give you that.
That won't give you that either.
Oh,
2 and 18.
12.
12 and 3.
Make sure I wrote down the problem right. Oops, sorry.
Yeah, we literally done ran through everything that makes 36 right. And none of it's working.
It's dyslexia. That's supposed to be 60, 63. Sorry.
Okay, now we got something 9 and 7.
All right, 9 and 7.
That should have worked.
and the.
All right, so 9 and 7.
The 7
Yeah.
is negative.
Now, no, positive will be with the 9.
Yeah,
Yeah,
because we got the positive 2x.
Yeah. And always check because you want that 2x. So let me just go here so I don't mess this part up. I'm going to just go here and check. So I got to make sure that the outer and the inner add up to be this middle. So the outer is negative 7x, the inner is 9x. When I add them up, I do get
2x.
2x. Okay, so now, now I have two factors whose product is 0. So according to the zero factor property, I'm going to set each one equal to 0. So I'm saying this, x plus 9 equals 0, and x minus 7 equals 0. And notice I went from a quadratic to two, what kind of equation are these?
Linear.
Linear. So what's x here?
Negative
Negative
9.
9.
What's
and
x here?
Positive 7.
Positive 7. So those are your two solutions.
So we just got to break it down using factoring, and then
All right.
we get that. That's
So you're going to go through these steps. So first of all, you're going to make sure it's in standard form. Step 1, make sure the equation is in standard form. So standard form means that it's got to be in descending order, and it's got to be equal to what? 0. All right, so descending order equal to 0. That was just step 1. Step 2, then, once it's in standard form, step 2 is to factor. And then step 3 is to use the zero factor property. And then they have a step 4 which says check your solutions, but they always do that. But you're not going to have time to check on a test. But you can check it. And let's go ahead and check it because some of you on that first test, when you had to evaluate an equation, some of you messed up with something like this. So let's just check it. Let's do the negative 9. Let's see if negative 9 works. So wherever we see the variable x, what do I plug in? Negative 9. So I get negative 9 squared, right?
Mhm.
Notice I have negative 9 in parentheses,
Mhm.
plus 2 times x. What's x?
Mhm.
Minus 63, and I want to see if that's going to equal 0. What's negative 9 squared?
81,
What's 2 times a negative 9?
18,
Negative 18,
negative.
and then minus 63. Okay, so on your calculator, 81 minus 18, whatever that is, and then
63,
63, and then subtract 63, and you get what?
0.
0, which is what you wanted. All right, so negative 9 works. If you plug in 7, it'll work also. Okay? All right, so step 1 is to do what?
Standard form.
Standard form. Then you're going to factor. And then you're going to use what property?
Zero factor.
Zero factor property.
Will all quadratic equations have two answers?
No. Oh, quadratic? Yes. Well, let me rephrase it. Let's do this one. Suppose we had x squared minus 12x plus 36. Let's do this. Equal negative 36. So x squared minus 12x equal a negative 36.
So what is this? This is just, you gotta move some stuff around.
What's step 1?
Standard form.
Standard form. Is this in standard form?
No.
So you,
No.
so you add 36 to both sides?
Mhm. And equal to 0. So x squared minus 12x plus 36 equal 0. So you have to put this in standard form. Remember, this is standard form. So descending order equal to 0. What's the next step?
Factor
Factor.
X on both sides. And 6 and 6.
Okay.
And it's gotta be a negative.
All right. Now, what's the next step?
Factor for 0.
Said what? So I'm using a zero factor
Zero
property. So I said each factor equals 0. But what do you say about these two factors?
They're the same.
They're the same, so you just need one of them. So x minus 6 equal
0.
0. So x has to be what?
6.
6. So here I only have how many distinct solutions?
One.
Just one. So I have one solution. Now,
Because it's a perfect square.
it's a perfect square trinomial. Have one solution, but in next semester you're gonna hear the word double root. So this is a double root because it occurred how many times as a solution? Twice. So your question was, are you always going to have two solutions? No. This is one solution.
But it's the same.
It occurred twice, though. All right, so this would be a double root. Root meaning solution. But in the answer on the blank, you would just say x equal what? 6. Here you'd say x equal negative 9, comma, x equal 7.
Okay.
Right.
You want us to put, never mind. That was a.
Just go ahead and write on the blank, just put x equal negative 9, x equals 7. Now, the mistake people make is this. Don't do this. Don't put negative 9, comma 7, put that in parentheses. Don't do that. That's wrong.
Because that's not a point.
It's not a point. It's not an interval. Okay? This, if you put it like this, if you put it like this, it looks like a point, and you're saying x negative 9 and y is 7. That's not true. So don't do that. Just say x equal negative 9, comma, x equal 7. X equals 6. Okay? All right. Now, okay, so suppose you had this. And this is going to be number 10. And that's on page 424. All right, suppose you had 2x times x plus 12 equals 0. So notice, though, it's already factored, correct?
Yeah.
All right, so,
X equals negative 12.
All right, I agree that's one of the solutions.
Or it can be 0.
All right, so you said each factor equal to 0. All right, so you can think of it this way. You see this x plus 12? That's one of my factors. And see this 2x that's together right here? I can think of that as another factor.
Mhm.
Although technically, it's really three things multiplied together. Three factors multiplied together, because one of them is 2. Remember, factors are separated by the word multiply. So when I read this, I'm saying 2 times what?
X.
X times what?
X plus
X plus 12. So really, you have how many factors here? 3. And the zero factor property says it said each one equal to 0, right?
Mhm.
So listen to this. So you said each one equal to 0. So you're going to say 2 equals 0, x equals 0, x plus 12 equals 0, correct? But this doesn't make any sense because 2 cannot equal what?
0.
0. So you just throw that one away. So one of your solutions is this, because x is already by itself.
Mhm.
And over here, what's x?
-12.
So you have how many solutions?
2.
2, and they are 0 and
0 and X
negative
equals
12. What some people do, though, is they do what I just did. So see how I put the 2x together? That monomial? So they'll say 2x equals 0, which means that x is what? 0. And they'll say x plus 12 equals 0, which means x is
Negative 12.
-12. All right? Okay, but technically that's really 3 factors you're multiplying together. 2 is a factor, x is a factor, x plus 12 is a factor. But sometimes it helps if you underline your factors. So it's okay to put 2x together.
Mhm.
So when is this thing right here that I have underlined equal to 0? When x is what?
0.
When is this thing I have underlined right here equal to 0? When x is negative 12. 14. You have 9x plus 1 times 4x minus 3 equals 0.
Okay.
Is there already a factor? Is there already a factor?
Yes.
Yes. You have a product that's equal to 0. Now, is this a quadratic equation, though?
No,
Why not?
because there's no exponent of 2.
Yes, there is. If I follow this out, what's 9x times 4x?
36X.
36x squared. So this is a quadratic equation, right?
Okay.
It's a quadratic equation that's already been factored.
Okay, so it kind of slipped past
This-
in a sense.
This is quadratic.
Okay.
This is also quadratic. Y'all guys, this is also a quadratic equation. It's already been factored for you.
Are there going to
Because what's 2x times x?
2X squared.
2x squared. It's a quadratic equation.
will we be required to identify a notation as being quadratic or not?
Yeah, you do need to know that. Next semester, depending on what kind of equation it is how you're going to solve it. So you solve a linear equation different than you would a quadratic. Next semester, if you have a rational equation, you're going to solve that differently than others. A radical equation is solved differently than others. So you need to know what kind of equations you have.
You really
So
make
this-
me dread math.
Huh?
You make me dread math.
Why?
It promises that it's always going to keep getting harder.
No, I mean, you're going through the process. So yes, it is going to look harder and harder, but you got to know all these prerequisite skills in order to get to that point.
It's going to explode.
So if you're missing some prerequisite skills, you're going to struggle with some concepts later on.
Okay. All right.
All right.
So it's already broken down. It's
So
already
it is
factored.
quadratic, though. It's already been factored for you. So now what's the next step?
9x plus 1
Tell me what you're using, though. You got to know the terminology. The zero factor property. So the zero factor property says if you have 2 or more factors whose product is 0, then, and it helps if you underline your factors, then one of them has to be 0.
But in this case, they're both 0.
Right, I mean, you said each one equal to 0.
Yeah.
So now notice I went from a quadratic to what?
Oh,
Linear. So how do you solve this linear equation?
minus the 0 or the 3, negative 3 on each side.
Wait, what?
Minus, oh, you're breaking it down, 9x equals 0?
No,
No,
9x equal negative 1.
yeah,
You bring the 1 over, right?
yeah.
You're solving a linear equation. Then divide both sides by what?
9.
9. So what's one of your solutions?
X
No.
equals negative 1/9.
Negative 1/9. Right? Over here, how to get x by itself? You're going to say 4x equal what?
3.
So divide both sides by 4. What's the other solution?
3/4.
3/4. So those are your two solutions. So one of your solutions is negative 1/9. The other solution is 3/4. Okay?
Fractions.
All right. Let's look at 24. 24.
It just-
You have x squared minus 3x equals 0.
All right, factor by grouping.
No.
No,
You factor by grouping, you have 4 terms.
Or,
How do you,
two
first of all, is
binomials.
this a quadratic equation?
Yes,
Yes.
So, is it in standard form?
Yes,
yes.
The next step is to factor. How do you factor the left-hand side?
X will put the two binomials into X. Or not.
GCF.
GCF, people.
Well, it's still X.
But you said two binomials. It's not two binomials, dude. It's a monomial because you have to factor out the x.
Oh.
X times what?
X minus 3.
X minus 3 equals 0. So it's not two binomials. Only one of them is a binomial. Okay, y'all. And remember your steps to factoring.
X equals.
Then you underline your factors.
3.
It helps if you underline your factors. So what's my first one I'm going to underline?
X,
X.
The x. What's the other one I'm going to underline?
X minus 3.
According to what property we're talking about,
0 factor.
Zero factor.
I'm going to set each one equal to 0 because one of them has to be 0. There's the only way I can get a product of zeros if one of them is 0. So x equals 0, x minus 3 equals 0, and then I solve each linear equation. Well, this one's already by itself, so what's one of my solutions?
What is it?
X equals
0. What's the other?
3.
equals 3.
X equals 3. Okay. So you got to remember your factoring. GCF is what you need to look at in some cases. All right. Now, let's look at 36. All right, 36, you have 6x squared plus 57x equal 30. So 6x squared plus 57x equal 30.
Negative.
You gotta subtract
Standard form.
30.
Okay? So it's in descending order, it's in standard form. What's the next step? Factor? All right. What do you try for 6x squared?
2 and 3 or 6 and 1.
All right, let's try 3 and 2. What do you want to try for 30?
6 and 5.
6
What do you
and
gotta-
5?
What do you got to come up with? 57?
Oh, wait.
Mhm.
Oh,
15.
No,
15 and 2, 10 and 3, 30 and 1. 15, 2,
it's
10
gonna
and
come
3.
57 though.
I'm using big numbers here. I'm trying to find out. 30 and 1.
You want to try 31?
Sure.
Okay, if you,
30 and 1.
you want to try 31.
Oh, okay, yeah.
All right, where you want to put the 30?
Oh, that's a positive 57.
Why with the 2?
Because it's.
Oh, 'cause it'd be your 60.
If you put it with the 3, right?
Okay, all right, now listen to what she said, okay? She says, well, if I put it here, then that means the GCF is 3, which means I could take it out of 3 here.
Yeah, so that's a no-no.
So,
You sure about that? You could have factored out at 3 to begin with.
Oh, it's 3 times 19. 3 times 19 is 57.
Yeah, all these are divisible by 3.
Dang it, Mom.
No, it's all right. But notice that you could put the 30 here. So I'm going to do this where we do take out the 3. So I can put the 30 here, and I can put the 1 here. Now the last sign's negative, right?
Mm-hmm.
So we got to make so that means these signs in here are different. But I got to make sure I get a positive 57. So what's the outer?
3x.
What's the inner?
60x.
And when I and I'm gonna subtract because they're different, and when I subtract, do I get the 57?
Yeah.
Yes.
So you
So
need
the
the,
three is negative, yeah.
Okay, so that means this is negative and this is
positive.
positive.
And the-
So I want you to notice though, and even though you didn't take out the GCF, it's okay if you don't here because you're solving an equation. It takes care of itself in the end.
It's one of those things that just
So-
randomly works out.
So
I love it.
now I can use the zero factor property, correct?
Mm-hmm.
So I can set each of these equal to 0. So 3x plus 30 equals 0. And what's the other equation?
2x minus 1 equals 0.
So here 3x equal a. Taking you a long time to solve a linear equation. 3x equal what?
-3.
Negative 30.
30, I mean, yeah.
Divide both sides by
3.
3.
X
So what's one of your
equals
solutions? Negative 10?
Mhm.
Over here. What does 2x equal? Guys, taking a long time to solve this linear equation. What does 2x equal?
1/2.
No, what does 2x equal?
Positive.
Positive 1. What's the next step?
Divide by
Divide by
2.
2.
So what does x equal?
1/2.
1/2. So those are your two solutions.
Mhm.
Now, if you would have noticed though,
If we would have did it the other way.
all right, so when solving when factoring, you always want to look for the GCF first, if possible. It does help. So I could have taken out a 3 to begin with. So I would get 3 times, and then what would this be?
2x squared plus 19x minus 10.
Minus 10. Then I go off to the side, and I see if I can factor this trinomial further.
You can't.
Yeah, you can,
Can. What's the 19?
because we did it here. So you should be able to do it here. What are the possibilities for 2x squared? There's only one. 2x and x. Okay, give me possibilities for 10. 5, 2, 10, and 1. What do you want to try?
You're trying to get a 19.
10 and 1. Okay, 10 and 1. I'm going to ask you this. Can I put the 10 here?
No.
No, because that means I can take out a,
5.
no,
Two.
a 2, which means all these are divisible by 2, and are they?
No.
No. So the 10 has to go here, and the 1 has to go here. And then the last sign's negative. That means these signs in here are different. I just got to look at the outer and the inner. What's the outer?
20x.
What's the inner?
X.
When I subtract, when I get the 19?
Yes.
So that means this has to be positive, this has to be
Negative.
negative, which means this is
Positive.
positive, this is
Negative.
negative. So I'm going to rewrite this here. So I get 3 times 2x minus 1 times x plus 10 equal 0. Okay? Now, how many factors do you see here? 3. There are 3.
But one of them
3.
can get to 0.
Okay, right. One of them, the 3, can never be 0. It's always going to be what?
2
Three.
answers.
3. So the only factors that's going to help me are the ones that contain the variable. These are the only 2 factors that contain the variable. This factor is 3. 3 can never equal what?
0.
0.
'Cause it's
So then you said each one of these equal to 0. 2x minus 1 equals 0. X plus 10 equals 0.
divide by, or add 1, so it would be 2x equals 1 divided by 2, and x equals 1/2.
Okay?
And then you subtract 10, so x equals negative 10 divided
Right.
by that. Or wait, no, that's it. Never mind. You don't have to do any division.
So you get the same answer. All right. Now, another way you could have done this. Now, most of you would not have noticed that this was, you could have taken out a 3. So you, for the most part, you would have had to do it this way for most of you.
I didn't, immediately when you said it was divisible by 3, I did 57 divided by 3, but you don't think about it because it's a
That's a
It's
large number.
57, it's odd, I mean, you
Yeah.
don't think about it like that.
Right, right. You think it's prime.
Yeah,
But it's not
That's
prime.
immediately what I first thought.
Yeah, but 57 is not prime. But then you got to be careful though, because when we talked about, well, the 30 cannot be here because that means you can take out a 3,
Mhm.
then
Would've thrown
she
it
would have probably put the 30 here and then realized it didn't work either and then would have probably given up. So if the 30 goes here and it works, then that means that originally you could have taken out a what?
The
A
3.
3. But we are dealing with equations, so another way you could have done this, I just want you to be aware of that, is this. So I'm going to write this part right here again. All right, so let's assume we know that all 3 terms of GCF is 3. We know that, right?
Mhm.
Okay. So this is the equation, correct? And so what you do to one side, you have to do to the other. So if I know that the GCF here of all these 3 terms is 3, then I could divide both sides by 3. And then that means that I would have to divide each of these terms by 3. So what's 6x squared divided by 3?
2x.
2x squared. What's 57x divided by 3?
19.
And what's 30 divided by 3?
10,
And what's 0 divided by 3?
0.
And you just factor this. So the difference between this and this one is that here I factor out a 3. Here I'm dividing both sides by what?
3.
3. And the only reason why this works right here where you divide both sides by 3 because this is an equation. That's the only reason. So so here you divide by 3 and remember it's okay to get rid of that 3 because we never did use it, right?
No.
3 is never equal to what?
0.
0. So then I factor this. So 2x, x, 10, 1. Remember that?
Mhm.
And that was minus and plus. And then I set each of these equal to 0. Here I had that extra 3, but it was never used to begin with. So 2x plus 1 equals 0. X minus 10 equals 0. So 2x equals negative 1. X is negative 1/2. Here x is 10. Okay? All right, so let's look at 34. Don't make 34 difficult. Think about what we just talked about.
You control what goes on that paper.
I know.
Making it difficult. Is that?
What is
it's
that?
Negative
72?
2y squared. Negative 2y squared plus 72 equals 0.
Okay. I thought it was 7L for a second.
Negative 2y squared plus 72 equals 0. And see, it's in standard form, but you're missing one term here. You're missing that y term. But think about what we just talked about. How can you deal with this?
Y equals 0, huh?
No, y can be 0. Because
Negative,
he went right away and said y is 0.
Oh,
Alright.
because then you're adding the 72.
Yeah, because and if y is 0, then this is 0, but 0 plus 72 is not equal to 0.
That ain't gonna work. So it has to, that left side has to wind up being a negative 72.
No, you're not. You got to do this by factoring.
Oh,
You need another y.
No, you don't.
Can you factor out a -1? No?
Or okay, she said factor out -1. Why -1?
Oh, no, I'm looking at the negative sign.
Come on, guys. What's the GCF?
oh, negative 2.
-2. Now forget about the GCF. GCF is -2. -2 times what?
Y squared plus negative or minus, sorry, negative 36.
36.
All right, so that's where I'm at. Anything else?
Yeah,
yeah.
the y squared, you have difference in 2 squared.
Difference of 2 squares. That's what you worked on the last 2 class periods. So I can factor this further.
Yeah.
So that's negative 2 times what?
Y,
Y plus six,
plus-
minus-
Okay, y plus 6, y minus 6 equals 0. So now how many factors are being multiplied together? 3. One of them is negative 2. Is that going to help me at all?
No.
No. So I'm going to unalign the two factors that will help me. What are they?
Y
X,
plus 6,
Y,
Y minus
minus- yeah.
And what do I do to those two factors? Set them equal to 0. So what's y over here?
Negative 6,
What's y over here?
6.
Those are your two solutions. So you got to remember things you've learned. And you're forgetting about the GCF. Taking out the GCF would have helped you here. Taking out the over here, it was not necessary. It was not necessary to have taken out the GCF because we were still able to factor, right? Here, you really needed to take out the GCF because you looked at this and you didn't know what to do. Once I took out GCF, then you noticed that, hey, at least one of you did. You noticed that this is a difference of two squares. And then you can factor it. So you got to remember all the stuff we talked about in terms of factoring. Now, look at 34 again. And still think about the GCF. What's the GCF here?
Negative 2.
-2. So, just like we did here, remember when let's see if I can find that page. Where, right here, where we said the GCF was 3, so I divided both sides by 3. We could do the same thing here. The GCF is -2, so I could divide both sides by what?
Negative 2.
-2. What's -2y squared divided by -2?
Y squared.
What's a positive 72 divided by -2?
Negative
Negative
36.
36.
And what's 0 divided by -2?
0.
So I can factor this now. How do you factor y squared minus 36?
Y,
Y
plus
plus
6, y minus 6,
Okay.
or vice versa.
Then I said each one equal to 0.
And then you get your
Get your answer.
positive
You get
6
your
and
answer.
negative 6.
So y is 6 and -6. Okay, so either way is fine, but you had to use the fact that the GCF was -2. Otherwise, you would not have known what to do. So you got to look for GCF. All right, let's look at 52. 52. All right, 52, you have 4y squared minus 81 equal 0. What do you think?
difference of 2 squares.
Difference of two squares. Now the GCF is 1, but it's still the difference of two squares. How do you factor this?
2y minus 9, 2y plus 9.
Yep. Right? 2y minus 9, 2y plus 9. Because 9 times 9 is 81, and 2y times 2y is
4y.
4y squared. Now what's the next step?
Set them both equal to 0.
Yep. So 2y minus 9 equals 0. 2y plus 9 equals 0. So notice I went from a quadratic equation to linear. Some of you have trouble solving a linear equation. What does 2y equal?
9,
9.
So what does y equal?
4.5,
Or 9 divided by?
2.
2. Over here, what does 2y equal?
Negative 9,
What does y equal?
negative 9 halves.
So you
Do
do
you mind
solutions.
if do you want it broken down, or you don't care if it's a fraction like that?
I'd leave it as a fraction.
Okay, I mean,
He's talking about writing as a mixed number versus, I'd like, just leave it as an improper fraction.
okay.
All right, now you see how they're opposites?
Mm-hmm.
So you could have also written it like this. Y equal plus or minus 9 halves. Okay, it does not matter. You see, they're the same, right? Your solutions are positive 9/2 or a what?
Negative.
Negative 9/2.
I like that, because you only have to write a little bit less.
You're
Plus-
saving-
plus
saving
or
You're
minus.
saving
graphite.
yourself a half of a second.
He's saving graphite.
Hey, what if I need that half a second for something else?
That's true. 62. You have 3x squared minus 6x minus 9 equals 0.
GCF 3.
Okay, so again, you notice the GCF was 3, but even if you didn't notice, it would not matter here, right? Because you're solving a quadratic equation. So it doesn't matter whether you leave it in there or take it out. Just like, remember that other one?
Mm-hmm.
Now, the one we did here, it did matter because most of you did not notice that this was the difference of two squares. So here you had to deal with the GCF. You don't have to here. Now, let me say this. On your test, on the third test, there'll be mixed. So you have some of these and some that will say factoring. So see how this says solve?
Mm-hmm.
What if, and I will come back and do both of them, but what if the problem just said this? What if on the third test it said factor?
Then you gotta do GCF.
Okay, remember, factoring, that's not an equation. It just said what? Factor. So here you, remember, to factor, first thing you gotta do is do the GCF.
So 3 times.
So you would have to take out a 3. It'll be 3 times,
X squared minus 2x minus 3.
and then you would go off to the side and see if you can factor this x squared minus 2x minus 3, which you could. What works?
X. And 1 and 3.
The 3 has to be,
One's negative and the 3 is positive.
no, 3 is negative.
Negative, because you're gonna end up.
Oh,
with
okay, you
negative.
gotta go with negative too, okay.
So what would be the answer in the blank you would have to give me?
3 times x minus 3 times x plus 1,
Okay,
and that's factored out.
that's factoring. Okay. Now, on this one though, you're solving.
So you could divide.
You could divide both sides by 3. You could factor out at 3. You didn't even have to factor if you wanted to. You could have gone straight to the two binomials. You can do that. You can go straight to the two binomials, but keep in mind that there'll be some problems that's going to say factor and be some problems going to say solve.
So is it better just to play it safe and always factor?
Factor out the GCF, yes. Yeah. So this one you can go directly to the binomials. This one you can factor out the 3 first. If you factor out the 3, what would you get?
X squared minus 2x minus 3.
Right. And then you would factor this trinomial, which we already did. It was 3 times x minus 3 times x plus 1.
Yeah.
And then how many factors do you see here?
3.
3?
Only 2 of them do you get.
Right. These right here will be the only 2 you're going to use because 3 can never equal 0. So x minus 3 equals 0. X plus 1 equals 0. So what's x here?
3.
Here?
Negative 1.
All right. Let's do this one where we did not take out the GCF. So what are the possibilities of 3x squared?
2.
3 and
3 and 1.
Yeah, 3 and 1.
So 3x and x. Okay, what about 9? There's 9, 1, and
3.
3, 3. What are you going to try?
Well, you gotta come up with
3,
a
3?
negative- You gotta come up with a negative 6, so it's gonna be 3, 3.
Okay. So 3, 3. So it doesn't matter where I put the 3's, right? Now remember, if you're not careful, you're gonna say, well, that means I could take out a 3 here, and you probably could say, so that can't be it. No, you're fine because they were already divisible by what? 3.
Mm-hmm.
So you need this to be negative. So that means this one has to be
Positive.
no,
Negative.
Oh, negative.
Negative
because
and
that's a
positive.
negative 9, right?
Yeah.
And this has to be a okay. Then you said each one of these equal to 0. So 3x plus 3 equals 0. X minus 3 equals 0. So notice I went from a quadratic equation to 2 linear. So 3x equal a,
Negative
Negative
3.
so that means x is a negative 1. Because Y'all see that, right?
Yeah, because
'Cause
you have to subtract the 3.
you have to divide-
Your 3x.
Right. So you divide both sides by 3. So x is -1. Over here, what's x?
Minus 3 equals 1.
3. So notice it didn't matter whether you took it out or didn't. Now the other thing you could have done was divide both sides by
3.
3. What's 3x squared divided by 3?
X squared,
What's negative 6x divided by 3?
negative 2x,
What's 9 divided by 3?
negative 3.
And then you factor.
X on both sides.
So xx, 3, 1. 3 has to be negative, 1 has to be
Positive.
positive. Say each one equal to 0, the zero factor property. So x minus 3 equals 0. X plus 1 equals 0. So what's x?
3,
3.
What's x?
negative 1.
Okay, so either one of these is fine. It works. But notice this said solve. This said solve. So notice the different ways you can get the answer. This said factor, and there's only one way. Right?
Mm-hmm.
Okay. All right, so that's 62. All right, let's look at, all right, let's look at 72. 72. All right, so remember we dealt with quadratic equations. All right, now 72 looks like this. 3x cubed minus 7x equals 0. Don't make it difficult. This is not quadratic.
You gotta make it quadratic.
No, just listen though. It's not quadratic, right?
Mhm.
Because the quadratic equation, the largest exponent has to be
2.
2. What's the largest exponent?
3.
So this is cubic. That's a cubic equation. But it doesn't matter. I can still do this using what we know. What do we know about solving? Now, this is really called a polynomial equation. You'll learn about that next semester. Do this the same way you've been doing it. What's the first thing you're going to look for? GCF. What's the GCF? X. So here you have to use the GCF. So you factor out the x. Now don't divide both sides by x. You can only, so you may say, well, you divided here. That's because I divided by a number. You can only divide by numbers. You can't divide by variables, okay? Cannot divide by variables. I want to divide by numbers. So here you have to factor out the x. So x times what?
3x squared minus 7.
All right, I think hold on. I probably did it again. Hold on. 72. Shoot. All right. 27. I know.
Okay.
Let's go back and redo this.
You get your GCF?
What's the GCF?
3.
3x. 3x. All right, so factor out the 3x. 3x times what?
X squared minus 9 equals 0.
Okay, what else can you do? Difference of 2
Yeah.
squares, this one. So that's 3x times what two binomials?
X minus 3x plus 3.
There you go.
Wow, I'm learning.
All right. Now, how many factors do you see here?
3, but you're only getting.
No.
There are really 4. 3 is 1. 3 times, what's the other? X is the other. What's the other?
X.
X minus 3. What's the other? X plus 3. Although, there are 4, but although we normally put this together
Right.
and these together, or these by themselves.
So x equals.
So you said each one equal to what?
0.
0. So you're going to say 3x equals 0, which means x has to be what?
Equals 0.
0. So 0 is a solution.
X minus 3 equals 0.
So notice I went from a cubic equation to 3 linear.
So x equals 3.
And then X equals negative 3.
Yeah.
All right, so how many solutions do I have here?
3.
3.
3. So one of the things you'll learn next semester in terms of polynomial equations is that the largest exponent, what's the largest exponent?
3.
That means you're going to have at most 3 solutions. And how many did I have here?
3.
3.
So the larger the exponent, the more solutions you'll have.
Mhm. Now, so you may say, well, why is the title of this section quadratic equations when this was not quadratic, right? That's because one of your factors was what? Quadratic.
Yeah,
That's why. One of your factors was quadratic.
that's a
I can see
loophole
it getting
that
one
was
where
exploited.
the exponent's like
It was.
7 or something like that.
Yeah.
Here's your one homework.
So even though this was, the original problem was not quadratic, you still did it the same way you did the quadratic ones.
Okay.
So let's look at this. All right, 66. We have 36x squared, x cubed, plus x squared, minus 21x equal 0. Now remember, I always look for standard form. Is it in standard form?
Mhm.
Yeah, it's in descending order, it's equal to 0. Although it's not quadratic, it is cubic. All right, so that's what I have. So what are you going to do?
GCF,
GCF, what's the GCF?
X squared. No,
X squared?
X.
It's just x, right?
X times 36x squared plus x minus 21 equals 0.
All right, what are you going to do next? All right, so see if you can factor this trinomial, 36x squared plus x minus 21. I'll give you 1 minute to try that.
Looks like you can.
No, you can. Come on, dude. All right, so 9x plus 7 times 4x minus 3, and it does work, because when you follow it, you do get this back. Make sure you figure out what you did wrong if you didn't get this. Any questions before we finish this? Okay, so now I'm going to rewrite this trinomial using those two factors. Don't forget the x, though, so it's x times 9x plus 7, 4x minus 3 equal 0. How many factors are being multiplied together?
1, 2, 3.
So 3. What are they? X, what's the other?
9x.
What's the other?
4x minus
Okay.
3.
So you set each one equal to 0. Set each one equal to 0. I'm using the 0 factor property.
4,
And notice I went from a cubic equation. Now, even though this section is titled quadratic, what made it quadratic was only this part here. So then I factored this quadratic and I set each one equal to 0. And then I went from a cubic equation to 3 linear. Here, x already by itself, so that's 0. Okay, here I get 9x equal a negative 7, so x has to equal a, come on guys,
Oh, negative 7 ninths.
negative 7 ninths. Here 4x equal,
Positive
3, so x has to equal,
4/3.
no, 3/4. Divide both sides by 4.
Ah, my bad. My bad.
Okay, so there's your 3 solutions. X equals 0, x equal negative 7 ninths, and x equal 3/4. Okay? You gotta know how to factor to do this. All right, 70. Look at 70. Okay, 70, the way they have it written is this way. 9y equal 6y squared.
What?
Thanks, Matt.
So you got to subtract 9y from both sides?
Okay, so put it in
Descending order.
standard form, descending order. So he wants to bring the 9y to the other side. So remember one of the things we talked about last class period was to try and make the squared term positive coefficient.
Mhm.
So my squared term, see this 6 is positive, right?
Mhm.
So let's bring everything to the other side. So now, I also want to remind you this. We could have done it this way as well. Watch. So do you all agree that 7 equals 5 plus 2, correct?
Yes,
But in 5 plus 2 also equal to what?
7.
7. So does it matter
No.
whether I transpose the sides or not?
Why?
Does not matter. So,
No.
so right here, if I wanted to, instead of saying 9y equals 6y squared, I could have said 6y squared equal 9y.
Y.
Could have done that. And then bring the 9y to the left-hand side. So I get 6y squared, what else?
Minus negative y, 9y
Equal 0. So now it's in standard form. What are you going to do next?
factor.
Okay,
GCF.
GCF was 3,
Y.
3y. So I can factor out the 3y times what?
2y
Minus the 3
3.
equals 0.
Okay. Can I factor any further? No. You can't do anything else, right? You can't factor 2y minus 3. That's linear. And this is monomial. So what's the next step?
Uh,
Set each one equal to 0. So 3y and 2y minus 3. So if 3y equals 0, that means y has to be
0.
0. If 2y minus 3 equals 0, that means 2y has to equal
Plus 3.
3, which means y has to equal 3 halves. So those are your two solutions. Now 70. Okay, you just got to practice with this. You got to know factoring. You got to know the many times that taking out the GCF is going to be what you're going to have to do. Sometimes if you don't take out GCF, it's fine, but other times it's needed. Like here, it was needed. Taking out the GCF was needed here. Now let me ask you this. Same problem. Well, let me go do it here. So this is, you see the original problem? Could I have divided both sides by 3?
Yeah,
Yeah.
Yes,
you'd have gotten that 3y. and
because it's an
2y.
equation, right? It's an equation. So I could have divided both sides by 3.
So,
So watch.
so 3y equals 2y squared.
Right. And then I could transpose the sides still, right?
Mm-hmm.
So 2y squared equal 3y. Then put in standard form. I get 2y squared.
Minus 3y equals 0.
Now what's the next step?
You have
Set
to
each factor.
set
No. You got to factor first. GCF. So what's the GCF? Y. Here, the GCF was 3y. Here it's just what?
y.
Y. So notice the difference. But it doesn't matter. You're going to still get the two same solutions. So y times what?
2y
2y.
minus.
Sorry, minus 3.
And so now you see this part here? That's this part right here. You see it?
Yeah.
Without the 3. So then you said each one equal to 0. So what's so this says that y has to be
0.
0. Here I get 2y minus 3 equals 0, which means 2y has to equal
3 halves.
3, which means y has to equal 3 halves. Okay, so it did not matter what approach you took. But I want you to keep in mind, you might say, well, why didn't you divide by 3y? Because y is on both sides. Because you can never divide by the variable. If you do that, this y would have been gone. You would have missed one of your solutions.
And then that's no fun.
And then the thing is, you can never divide by a variable. So you lose a solution when you divide by variables. You only divide by numbers. All right, let's try. All right. So what I want you to think about is this. And we're going to finish this one next class period. This what, I mean, we're almost done with this. That's all this was. But you have to know how to factor to do these. I want you to think about this, though. Suppose I had this. Suppose I had, let me find it. Okay, suppose I had this, x times 4x minus 11 equal 3. We're not going to do this today because it'll take us a few more minutes to think about it.
Not quite, yeah.
But
Oh, I can see, yeah.
what could you do here? Let's think about this. What could you do?
Distributive property.
Well, why can't I just set each factor equal to 3? Because I have on the left side, it looks like it's factored, right? Yes or no?
Yeah,
Yeah,
that's 11.
that's 11, 4x minus 11.
So
Right.
It's not a three-factor property, it's a zero-factor property.
Okay, so she's saying, but I thought that in order to set these factors equal to a number, that number had to be what number?
Zero.
0. And it has to be 0. So setting each one of those equal to 3 is wrong. That property only works if their product's equal to what number?
0.
0.
You also have to make it a quadratic equation.
Right. But make sure you understand this here, and that's where some of you are going to mess up on the test. You're going to forget about the fact that when you set these factors equal to a number, that number has to be
Zero.
0. So you cannot say x equal 3 and 4x minus 11 equal 3.
Right.
It doesn't give you your solutions. So this has to be 0. So what you had to do first was what she mentioned. Do what on this side?
Distributive property.
Distribute first. And then put in standard form. And then do what? Factor. All right, so we're going to do that one next class period.
Distributive property and then subtract 3 from both sides and then you should be.
And then factor, and then now you can use a 0 factor property. So remind me to
4x
to do this
squared
one.
minus 11.
Yeah. 11x minus 3 equals 0. Put in descending order, factor, and then set each one equal to 0. Okay, so we'll do that next class period. But let's see what worksheets I can give you to start working on. So I want you to look at this one. So this is 6.6 part A. So you can do these. Actually, the first one's easy because it's already factored equal to 0, right? Second one's also already factored equal to 0. Here, this is not. What do you have to do here?
GCF, not GCF.
Factor. Yeah, the GCF is 1. You would look for the GCF. Factor and then set each factor equal to 0. On the back page, same thing here. Notice, though, the GCF, right? Put this in what first? Standard form. Put this in what first? Standard form. Okay, that's part A. Part B is where you have GCFs here. So what's a GCF here? 3. So you can do one of several things. You could factor out the 3. You could divide both sides by 3 and then go from there. It does not matter. Here, that goes back to what we did earlier where you have that double root. You factor, the factors are the same. What's this one right here?
4.
Difference of 2 squares. Here you put in standard form, GCF, factor, and then here, when to do this, and see where it says squared right here? What does 3x minus 5 squared mean?
3x minus 5 times 3x minus 5.
Equals 0, right?
You
And then you set,
Each factor,
but they're the same factor.
so you only need one.
You only need one. That goes back to what we did earlier. All right? So those are the 2 worksheets. Okay? So it's not difficult, but notice that none of these problems had anything to do with this one.
Okay.
But remind me to do one like that because you're going to see this on my math lab. I'm not going to sign my math lab just yet because there's at least one like this. So I gotta do this one. All right, but you can start working on these. So there's part A, part B, and this is part A. All right, so let's see.